Okay, day 4a, we're going to keep going with some new identities. We've got what's called a double angle identity. And a double angle, we're just looking at if it's sine 2u. And we can prove this pretty quickly. It says select any two of the identities above, above should be below, and prove them. Yeah, so I'm just going to do them real fast here. So think of this as, instead of sine 2u, think of that as sine u plus u, and we'll use our sum of sine identity here. So this would be sine u cosine u plus cosine u sine u, and notice those are basically the same thing, just different, being multiplied in a different order. So it's really just 2 sine u cosine u, and that's what we're trying to verify. So basically, it's if you could have a u here, if something you're trying to look at, if you were to say cut it in half or double it, whichever direction you want to go, you could use this theorem to find it. And down below here, for cosine, there's a couple different ones here. If we do cosine, think of that as cosine u plus u. So split that up, it'd be cosine this u times cosine that u, and then it'd be minus sine the first u times sine the second u, and this is cosine squared u minus sine squared u, and that would be the first one. These guys, kind of same idea, using variations of the trig identity, so I won't do all of them. So variations of, not trig, of Pythagorean identity. Yeah, and then this one here, think of this as tan u plus u. Same thing, when you're done, you'll have that. Okay, so kind of save some time here. So these guys here, just be able to use, again, there's 3 of them here, so cosine actually has 3 different ones you can use depending on what you're trying to do. Sine and cosine just have 1. So write each expression as a single trig function. So basically, what were they trying to do? So if they're using 2 sine 0.6 cosine 0.6, that must have been they were doing the sine of 2 times 0.6. Whoops, 2 times 0.6, so they were doing sine 1.2. If I combine it into a single one. 2 sine 3 cosine 3, again, same thing. That's your u. U is 3, so it'd be sine 2 times 3, or sine 6. Which one does this match up with? You can look up above here, it's with cosine. So your u was 0.45, so cosine of 2 times 0.45, which would be cosine 0.9. And then this guy here, same idea as over there, it's cosine. And now your u is pi over 10, so it'll be 2 times pi over 10, which is going to be pi over 5, so cosine pi over 5. Okay, so this guy here, we're going to try to find what sine of 2 times theta is. Now we don't even know what theta is. We just know the sine of theta is 1/3, and theta is in the first quadrant. So we want to find the sine of 2 theta. So if theta isn't in the first quadrant, it's over here. Here's theta. Sine opposite of hypotenuse is 1/3. That means this would be 2 radical 2 if you use Pythagorean theorem. So it would be 2 radical 2. So what I want to do, if I want to find sine of 2 theta, well, I don't know what theta is. Maybe you're thinking I could use inverse sine to find theta, but let's not do that. I could do sine 2 theta by going 2 sine theta cosine theta, which would be 2, and in this case, sine theta is 1/3. Cosine would be adjacent over hypotenuse, so that would be 2 radical 2 over 3. So if I do some multiplying here, think of this as over 1. So 2, that'd be a 4 radical 2 over 9. So that would be the sine of 2 times theta, whatever theta is. If I want to do cosine of 2 theta, really pick any of these 3 that you want to do. It really doesn't matter which one you pick. I'll just pick the first one. It would be cosine squared theta minus sine squared theta. Well, the cosine theta we found over here was 2 radical 2 over 3. So I want to square that. Minus, and the sine of theta was 1/3. Well, square that. So this would be 8/9 minus 1/9. So it would be 7/9. All right, now a value of theta is defined. And now we want to evaluate what is sine 2 theta, cosine 2 theta, and tangent 2 theta given this information. Okay, so we want to find all of them. Let's see, so cosine of theta is -1/2, and this is the second quadrant. So from the second quadrant over here somewhere, it's see, adjacent over hypotenuse would be -1 over 2. Now we could put 1 over 2 like this, and that's fine. Yeah, we could reduce it though too. Let's say, so if this, let's say this was 1, this would be a half then. We'll put out the unit circle, so we'll scale everything down. This would be a radical 3 over 2. I think it's going to be easier that way when we do our multiplications if we have it in a unit circle with the hypotenuse as 1. So the cosine, oops, sorry, we'll do the sine first. So sine of 2 theta, remember, is 2 sine theta cosine theta. Cosine 2 theta, really pick one out. Maybe I'll pick the second one. I'll do the second one instead. So it'll be 2 cosine theta squared minus 1. And then tangent 2 theta is going to be 2 tangent theta over 1 minus tangent squared theta. So plug these values in. 2 times the sine would be opposite of hypotenuse. That'd be a radical 3 over 2. Cosine is -1/2. So multiply all this together. Let's see, cancel out the 2's here. So it'll be negative radical 3 over 2. This one here, 2, and we just said that the cosine was -1/2, so it would be 1/4 minus 1. So it would be 2/4, which is a half minus 1 would be -1/2. And then for the tangent, 2 times, and then the tangent is opposite over adjacent, so it would be negative radical 3 over 1 minus, and then negative radical 3 squared is just going to be 3. So it'll be 2 minus radical 3 over -2. Sorry, this is multiplied, so it'll be -2 times radical 3. -2 times radical 3 divided by 2. Cancel those out, cancel the negative, so it'll just be radical 3. All right, now this one over here, if we know that the tangent is 0.75 and it's in the, see, this would be the third quadrant. So we're down here in this third quadrant. And so third quadrant, and the tangent, the opposite over the adjacent is 0.75. I'm going to think of that as 3 over 4. So opposite, so the opposite would be 3, and this one would be 4. And the reason why this is positive is because they're both negative. So -3 over -4, and then this means the hypotenuse would be a 5. Now the only reason I didn't have this be a 1 here like I did back here is because this isn't a reference triangle. 3, 4, 5 doesn't make a 30, 60, 90 or a 45, 45, 90. So I'm just going to make these whole numbers. You could do decimals with the same answers here, but so sine, sorry, sine 2 theta would be 2 sine theta cosine theta, which would be 2 times, and then the sine is opposite over hypotenuse, so that's -3/5. The cosine's adjacent, so it would be -4 over 5. Let's see here, so that would be, multiply that out, negative, so it would be 24 over 25. Cosine 2 theta, and just pick one, doesn't really matter. We'll just go with 2 cosine squared theta minus 1. So 2, and the cosine was -4/5. So if we square that, it'd be 16/25. Let's see, minus 1. So this would be 32/25 minus 25/25. So that would be 7/25. And then the tangent, that would be 2 tangent theta over 1 minus tangent squared theta. So 2, the tangent was 3/4, so that'd be, 9/16 on top over 1 minus, wait a second, don't square that yet, so 3/4, 1 minus 9/16 on bottom. If we, let's see here, yeah, so 16, I'll take everything times 16, so this would be, let me do this, so 6/4 over 1 minus 9/16. Take everything times 16, which means this is going to reduce by 4, so 4 times 6 is 24. This would be 16 minus 9, so 24/7. So 24/7. Okay, now backside, just got a couple identities we want to prove now. So instead of actually applying it and getting number answers, now I'm going to try to prove some identities. On this one, I would, looking at this guy, I think this side's more complicated, so I would work with this one. You could do some work with this one probably and get there. I just think it's going to be easier to go this route. So I'm going to square that guy. So that'd be sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. And the only reason I do that is because anytime we square that stuff, this Pythagorean, sine squared plus cosine squared is 1. So 1 plus 2 sine theta cosine theta. And on the front side, we got the identity. This is actually the same thing as sine 2 theta. So our double angle identity. So there we verified it. Over here, same idea. I'm on the left side. I'm going to do the exact same thing as I did here. So sine squared theta plus 2 sine theta cosine theta plus cosine squared theta on top over sine 2 theta. And you've got, that's a 1. So these together equal 1. So 1 plus 2 sine theta cosine theta on top over sine 2 theta. And then this one, same idea as before over here. We're kind of using the exact same thing we did here. That'd be plus sine 2 theta over sine 2 theta. You might be tempted to just cancel those out, but you can't. Let's split those up though. So right there is 1 over sine 2 theta plus sine 2 theta over sine 2 theta. And this is 1, so plus 1, and this, flip it over, cosecant 2 theta. So it does verify. Okay. And the last guy down here, we're going to solve this one. Okay. And a lot of options here. Because when you got cosine of 2 theta, there's three of them you can pick. And I just think it's going to be, I want the one that has a cosine squared in it. If you're looking here, here's your 3. So the one with cosine squared in it seems most helpful to me to use. So I'm going to take 1 plus cosine theta, and I'm going to replace this with 2 cosine squared theta minus 1. And I want to know when does that equal 0. See, so 1 minus 1 is gone, so I just got cosine theta plus 2 cosine squared theta equals 0. They both have a cosine in them. So 1 plus 2 cosine theta equals 0. And now either cosine theta equals 0 or this guy here, cosine theta equals, I'll bring the 1 over, be a minus 1, and then divide by 2, be negative 1/2. Okay, so looking on here, when are you going left or right 0? That'd be here or here. So that would be at pi over 2 and at 3 pi over 2. 3 pi over 2. And then when is my cosine negative 1/2? So when do I go over 1/2 this way? So I can go over and up, or I can go over and down. So this would be the negative 1/2 over. Well, if that's a 1/2 and this is 1, then this is radical 3 over 2 and radical 3 over 2. So those are 30, 60, 90 triangles. This is a 60-degree angle in here. So that's 60 degrees is pi over 3. So I'm pi over 3 short of a pi. So that'd be 2 pi over 3, 2/3 pi. And then I'm at pi over 3 more than pi. So it'd be 4 pi over 3. So, and then you could do the plus 2 pi if you want to find all of them idea. So hopefully that helps. And let me know if you have questions.